This is section 6.1, Angles of Polygons. The I can statement for this section: I can find and use the sum of the measures of the interior and exterior angles of a polygon. The diagonals on a polygon are a segment that connects non-consecutive vertices of a polygon. So if a figure has 4 sides, we can always draw one diagonal that goes from this vertice down to the one that it doesn't touch, and we could draw a separate diagonal that goes from this vertice down to the other vertice it does not touch. When you draw the diagonals, you're actually creating triangles. We know inside of a triangle there are 180 degrees. So if a figure has 4 sides, it's creating 2 triangles when you draw the diagonal. So I have 180 times 2, so there will be 360 degrees. On a pentagon, when we draw the diagonals, we're going to get 3 different triangles. So I have 180 times 3, which will give us 540 degrees. The next one's going to have 4 sections, then 5. If you notice, if there are 4 sides, then you multiply by 2. If there are 5 sides, we're going to multiply by 3. Each time you're multiplying by 2 less than the number of sides. So the formula we have to figure out how many degrees are in the interior of a polygon, we do 180 times n minus 2, where n is the number of sides. So again, if there are 4 sides, 4 minus 2 is 2. 180 times 2 gives us 360. So if we need to find the sum of the measures of the interior angles of a convex heptagon, heptagon has 7 sides. So we're going to do 180 times 7 minus 2. 7 minus 2 is 5. So the sum of our interior angles of a heptagon will always be 900 degrees. We need to find the measure of each interior angle of the quadrilateral. First, we need to recognize this is a quadrilateral, so it has 4 sides. So we're going to do 180 times 4 minus 2, or 180 times 2. So we do know there's going to be 360 degrees inside this polygon. Now so far we have 2 right angles. We know right angles add up to be, right angles are 90 degrees. So if we have 2 right angles, that's 180. So inside this polygon, we know we've used 180 degrees. The other 2 angles are 3x and x. And all 4 of those angles together should equal 360. If we combine like terms, 3x and x gives us 4x. And we take that 180 to the other side. Right now it's positive, so we need to subtract it to the other side. And that's going to leave us with 4x is equal to 180 degrees. Now this is 4 times x, so we're going to divide on both sides. And we're going to get x is equal to 45. So it says to find the measure of each interior angle. If x is 45, then 3 times x is 135 degrees. On this example, we have the same concept. It still has 4 sides, so we still know it's going to add up to 360 degrees. When we combine like terms, 2x plus 2x gives us 4x, plus x is 5x, plus another x gives us 6x. Now we have 6 times x. We want to get the x by itself, so we will divide both sides by 6. And we get x is 60. So if we substitute this back in, angle A and angle D will both be 60 degrees. And 2 times 60 is 120. So angles B and C will both be 120 degrees. Theorem 6.2 is the exterior angle sum theorem. If a polygon is convex, then the sum of the measures of the exterior angles, one at each vertex, will be 360 degrees. Now remember, you find those exterior angles by extending the sides. So on this example, if we add angles 1, 2, 3, 4, and 5 together, they will always add up to equal 360 degrees. So on this example, we have all of our exterior angles. We're going to add them all together. The exteriors always add up to 360. It doesn't matter how many sides that polygon has, the exterior angles will always be 360 degrees. So after we add all the angles together and set them equal to 360, we're going to combine like terms. 2x plus 5x gives us 7x, plus 6 is 13x, plus 3 is 16x. Now we can go with our constants. So negative 5 plus 2 is a negative 3. Negative 3 and negative 5 gives us negative 8. And negative 8 plus 10 gives us a positive 2. Now we're going to subtract 2 from both sides. Let's back up for a second because this is not just a 2, this is a 2x, so we do need to start over. So let's back up for a second. So when we write this out, now when we combine like terms, we have 2x and 5x is 7, plus 2x gives us 9, plus 6 gives us 15, plus 3 is 18x. Negative 5 and negative 5 is a negative 10, plus 10 gives us 0, or just 18x is equal to 360. Now we have 18 times x. We want to get the x by itself, so we will divide both sides by 18. And we will end up with x is equal to 20.